All right, welcome everybody. Thank you for hurrying back from lunch so that you could make it to Richard's talk. My name is Jeff Bigham. I'm from Carnegie Mellon University, and it's my great pleasure to be able to introduce Richard Ladner today. Richard has been a steadfast supporter of people with disabilities for more than 3 decades. His efforts have tangibly increased participation for people with disabilities in computing. His research has advanced the state of the art in access technology, and his advocacy has resulted in real improvements for people with disabilities in STEM fields. As many of you may already know, Richard began his academic career in computer science as a theorist and has been widely recognized for his contributions in that area. But as he has told me many times, he was already publishing in CHI in 1987 with his first paper which described a user interface for deaf-blind people. Since then, he has led a number of successful research projects centering around tactile graphics production, improving web accessibility, increasing the affordability of access technology, and developing mobile interfaces for people who are blind or deaf-blind. Richard also has a very long track record of engaging students with disabilities in computing. As just one example, he developed and led the Summer Academy for advancing deaf and hard of hearing students in computing, which brought more than 80 deaf high school students to the University of Washington to take introductory computer science courses to prepare them to pursue a computer science major in college. He leads the AccessComputing Alliance, which works to ensure that post-secondary institutions can fully include students with disabilities in computing courses and programs. And I think what's been most remarkable is Richard has also supported many students with disabilities personally. He has supervised numerous high school and undergraduate researchers with disabilities and has advised a number of PhD students with disabilities. The personal role Richard has had in ensuring these students were provided with what they needed to succeed seems to be, to me anyway, in talking to Richard, one of his achievements that he's most proud of. Richard has also expanded his impact and influence by educating a generation of accessibility researchers, many of which are here with us today. As a few examples, I guess, of some of the first ones, Anna Cavender is now an accessibility lead at Google and has brought captioning to Google Hangouts. Sean Kane, who's here somewhere, is a professor at Colorado, leading a research lab focused on access technology. Shawnee Giant's a researcher at Nokia, focusing on mobile accessibility, and on and on and on. I was fortunate enough to be one of those students, and I just wanted to share 2 quick lessons that I think Richard taught me. And one of those was that he taught me to make impact the primary goal of my research, not papers and not some abstract notion of research. He just taught me to design and build useful systems and deploy those systems so that they could actually be useful to people. And this is not exactly what everyone else tells you in graduate school. He also taught me to start with the assumption that people with disabilities can do anything anyone else can. And it was up to us to all come together to make sure that the sometimes inaccessible world didn't get in the way. I think that's a great perspective and one that I try to bring to the projects that I work on now. In any case, Richard is truly a very rare person. It's very difficult to find someone who is so active in service, research, and advocacy, and all supporting the goal of greater inclusion. I think we could all be very fortunate to accomplish just a fraction of what Richard has. And even though he's been threatening to retire for years, I have no doubt that he has a lot more to accomplish going forward. And so with that quite lengthy, but I still feel very much abbreviated introduction to Richard's accomplishments, I invite you all to help me welcome Richard, this year's SIGCHI Social Impact Award winner.
Wow. Can you guys hear me okay with this? Thank you, Jeff. That was very nicely said. And I have to admit that I've been very fortunate to have such great students like Jeff and Sean and Shawnee and all the other students. Jessica, who's down here. I'm probably missing some. Katie Baker, who's here. Shiri Azenkot. And so on. So I think they've really blessed me and my work and amplified what I'm doing. So today I'm going to talk about design for user empowerment. And at the last minute I decided that I would add one slide. I'm going to show you that one first. So this is a picture of my family taken back in 1946. And in there is my older sister, Sue, my younger sister, Jennifer, my twin brother, David, myself in the front, and my two parents. And it looks like, a post-war baby picture. But there is something about this that you don't see, that those two adults there are deaf. And so I was born into a deaf family. And I think that really shaped my career. Even though I was in theoretical computer science for over 30 years, maybe even 35 years. Actually, one of my theory papers was published just in 2013. There's no social impact award in theory. So I'm really happy to be in this new community, and it's really enriched me. And if you like, it's given me an encore career. And that's why it's so hard to retire, because I'm having so much fun. So that's a little introduction to my family. I should say a little bit more about my parents. They were not born deaf, but became deaf at an early age. My mother at 6 months and my father about 6 years. My father grew up in California, my mother in Michigan. They met at Gallaudet University. They did not fall in love there. They went their separate ways and corresponded by mail. They just kept in touch. And they fell in love over their correspondence. And their proposal to get married was through the mail. And in those days, that was the technology, right? About a 2-week turnaround to talk to somebody. And what do we have today? Instant messaging. We have so many things. The technology has changed. And I wonder if their lives would have been different with the new technology. On the other hand, I witnessed technology brought into their lives when the TTY teletypewriter came into existence in the really late 1960s, but really spread during the 1970s and early 1980s. And I saw the impact that I could be far away and I could talk to them directly with a TTY using texting. And that'll be one of the little talks, little segments I'm going to talk about today is the origin of personal texting. So that's kind of a little background about me, and I thought that would help you understand the rest of the talk and why I'm so passionate about getting more people with disabilities into HCI and computing fields generally. So that's my message for today. HCI needs more researchers with disabilities. Now there are some. In fact, there's a few in this room here. I just noticed Cheiko Asakawa came in, and your picture is on there. I hope that's okay with you. A couple of my students, Shiri Azenkot and Sean Kane, are here as well. Plus others, I know all these people. And they're exceptional, and they do great work. Some are deaf, some are blind, some have other kinds of disabilities. And some of these people I'm going to talk about a little bit more during the talk. And I'm going to explain why we need more people with disabilities in HCI. So the first reason is HCI needs their expertise and perspectives to spark innovation. Think about products that are built out there in the world for women. Can you imagine a product for women that doesn't have women on the design team? No, you can't. Not anymore. We need those women. What about products for, Asia? I think we should have people from Asia on those products. And products for disabilities, well, actually, almost all products are for people with disabilities. If you think about it, they're users. And I'm going to talk about them as users in just a moment. So actually, that's the only reason. They need their perspectives and expertise. So this is a brief outline. I'll talk a little bit about who they are, this group, the innovations driven by accessibility, some design paradigms, just briefly, design for empowerment, which is the title of this talk, and I'll talk at the end about AccessComputing, which is the project that Jeff mentioned earlier. So who are they? Well, it's 1 billion people worldwide. So if you look at the World Health Organization and all the other organizations that count, Worldwide, there are about 1 billion people. There's about 250 million deaf people, 250 million blind people. There's lots of other disabilities. These disabilities are caused congenitally from birth by wars. A lot of people have lost limbs in wars, and disease. So that's 15% of the world's population. So this is not a small number. These are a lot of users, and we should have more of them doing the design for the products that we produce. So a little bit about disabilities. I'm just going to be very broad. There's vision, blind, low vision, and colorblind. Hearing, deaf or hard of hearing. Speech, ability to speak, perhaps stuttering. Mobility, ability to walk, ability to use hands and arms, things like that. Cognition, dyslexia, short-term memory loss, dementia. Some of these disabilities are caused by aging. Not caused by aging, they just occur while you age. And there's multiple disabilities, people who are both deaf, for example, both deaf and blind. So I thought I'd go through the current thinking by the World Health Organization about what is disability. So I'm just quoting from their webpage. Disabilities is an umbrella term covering impairments, activity limitations, and participation restrictions. Disability is thus not a health problem. So the World Health Organization says disability is not a health problem. Overcoming the difficulties faced by people with disabilities requires inventions, that's us, to remove environmental and social barriers. So we, as HCI researchers and developers, are responsible to make this actually happen. So the important thing is that people with disabilities are us. I also want to mention the Convention on the Rights of Persons with Disabilities and what they say about technology. So this is Article 4G, to undertake or promote research and development of, and to promote the availability and use of new technologies, that's us, including information and communications technology, mobility aids, devices, and assistive technologies suitable for persons with disabilities, given priority to technologies at an affordable cost. So this is a, in quotes, call to arms. And over 150, I think 158 countries of the world have signed on to this treaty, including Canada and to a lesser extent the United States. Almost all the countries in Europe, places like Uganda in Africa have also signed on to this. So this is, we have a responsibility here to do something. I briefly want to talk about models of disability. How do you think about disability? And there are many ways to think about it, and I'm going to go through them. The medical model. Disabled people are patients who need treatment or cure. And if you think about it, this is very common. A lot of people become disabled during life, and so they want to get their function returned. And they go to doctors and they try to find ways to get that function returned. If they can't get it returned, then they need some way to get around it. So they might need a wheelchair, or they might need a walker, or whatever it is. A special education model. Disabled youth need some special education. So they're different. They need an education that's different than our education. And maybe it's not the same education after all, it's special. Rehabilitation model. So disabled people need assistive technology and training for employment and everyday life. And this is very common throughout the world. So this is a common model. Again, thinking of rehabilitation as, well, not getting your function back, but getting around the loss of that function. The legal model. Disabled people are citizens who have the rights and responsibilities like others. Access to public buildings, voting, television, telephone, and education are some of those rights. So this is following pretty much the Convention on the Rights of Persons with Disabilities idea. It's sort of a legal document. And finally, this is the model I grew up with, and you understand that. Disabled people are part of the diversity of life, not necessarily in need of treatment or cure. they do need access when possible. And again, that's us. This access is usually technology. Not always, but usually. So one final thing to say about who are they. They will be you if you live long enough. So, in fact, several people have come up to me during this conference have said and mentioned to me their new disability that they've gotten because they're like my age or older. So think about people with disabilities. It's not them, but us. So innovations driven by accessibility. So I always like to tell the OCR story. So optical character recognition is ubiquitous now, and you can get it on your smartphone and so on. But one of the early OCR machines was a Kurzweil machine, which was invented about 1976, and it was specifically for reading books out loud. You would take a page from a book or a document. It's sort of like a scanner, put it into the scanner, and then the thing read out loud what was under the scanner. So that was kind of early OCR. And then it became miniaturized on a smartphone. So the KNFB Reader Mobile is an example of that. And now, of course, it's on an iPhone with Prismo. And I'm sure there's other applications that do OCR as well on smartphones. There's Bookshare, which is a company in California, which is making as many books as, I think, about 100,000 books that have been made accessible through crowdsourcing. And they're all OCR books. And there's Google Books, which is kind of doing the same thing for all books that do not have copyrights, making them accessible to everybody. And why does Google do this? Because these books were lying around. They're probably useful to somebody, but there's no way to access them. There's no way to search them. So what is Google? They're the search company. So now these books are searchable. And I'm sure I think there's more than 1 million books. Somebody should tell me how many, maybe 3 million. Anybody from Google here? So accessibility innovations matter. So there's this sort of diagram. If you have an innovation for disability, it could become a solution for everyone, like optical character recognition. Also, there's speech synthesis in there as well, to read the book out loud from text. I'm going to mention 4 of these: the telephone, personal texting, speech recognition, and personal video chat. All of these are ubiquitous. Everybody uses them these days. But where did they come from? So the telephone. Well, Alexander Graham Bell invented the telephone. And it turns out that he was very interested in deafness. His wife was deaf. His mother was deaf. He was very interested in helping deaf children speak. And so I'm going to quote from an article that was in American Annals of the Deaf from 1887, which stated that the telephone was invented by A.G. Bell in his efforts of devising methods of exhibiting the vibrations of sound optically for use in teaching the deaf and dumb. Of course, we don't use that term deaf and dumb anymore, but in the late 1880s it was in common use. So Alexander Graham Bell wasn't trying to invent the telephone. He was trying to invent an assistive device, namely a device where deaf children could look and see what their speech looked like as some kind of signal. And he never finished that project, but he did. Sort of the technology needed to do that was a technology to take sound and convert it to an electronic signal and then reconvert that back to sound again with a microphone. So that's the kind of thing that he did, and it was motivated by accessibility. Personal texting by deaf people. So this is a TTY. I talked about that earlier. It's kind of a surplus Western Union teletype. And in the late 1960s and early 1970s, and even into the 1980s, you would find these in deaf people's homes. And in those particular homes, there was originally, before the TTY, no telephone. But then there was a telephone because this thing could be connected to the phone system by an acoustic modem, which, by the way, was invented by a deaf guy, Bob Whitebread. So back in the day, I can remember in 1970, no, maybe it was a little later, 1975, I had one of these in my home and in Seattle, and I could talk to my parents in real time for the first time in my life from a distance with a TTY. So there's that technology. It made a huge difference. It kept our family together, closer. We didn't have to write letters back and forth and wait those 2 weeks for the round trip. And then, of course, they got smaller. They're sort of a portable size one. And then, of course, we moved to SMS texting, which everybody does. So personal texting didn't start with BlackBerry. It started with deaf people on TTYs. So you see the pattern? That technology for people with disabilities can be useful for everyone. Speech recognition for hands-free access. So if you can't use your hands, but you can talk, then you can operate a computer because you can speak to it. So this is a picture of Ray Kurzweil from 1987 with the first commercial large vocabulary speech recognition system. And it was invented for people with disabilities originally. That's what Kurzweil's passion is. And of course, he went on and did a lot of other things as well. And then today, this is Sang-Mook Lee from Korea. I was just talking to some Koreans about him. He's very famous in Korea. He had a terrible accident and became totally paralyzed. So he's using something from Nuance, Dragon Naturally Speaking or something like that to communicate with others, to write letters and things like that. So something that was done for people with disability is still used for people with disability. It's still useful. Now, of course, we have Siri, and there's more and more speech applications coming out every day. And how many people use speech for input? Raise your hand. Okay, next year it'll be everybody, but it was a pretty big number, maybe a third of you. So it's becoming ubiquitous. Finally, I want to talk about the picture phone or video chat. So it's funny, I should talk about this today because this is the 50th anniversary of the World's Fair in New York, and they're having a big celebration, and I was watching a little news show about it, and darn it, they didn't show this picture phone. This was like the big novelty, or one of the big novelties at the World's Fair in 1964. So the idea was to have a video chat across a phone line. And you can see that there's a phone connected to it, kind of like that modem I talked about earlier. And so AT&T brought this out, and people loved it, especially deaf people. They were so excited that they were going to be able to talk to each other in sign language instead of trying to, they didn't have, TTYs weren't even out yet. They would have preferred sign language anyway. But it required too much bandwidth, and the only people that were really buying it were companies, and even those were kind of skeptical about wanting to see the other people because you might be able to detect their expressions that they were lying or something like that. So they wanted to stick to the old voice phones. So it was not much going on. I left out a slide here, and I shouldn't have, but I should mention around 2002, the company Sorensen from Utah built a picture phone. It's called a video phone. And deaf people started using that right away. And remember that TTY? Well, they're all in the closet now. Deaf people use a picture phone, or what's commonly called a video phone. But now it's ubiquitous. There's FaceTime, there's Skype, there's ZBRS, which is more specifically for deaf people, a little bit higher quality. So you see that voice chat, or video chat didn't start with FaceTime. It was going on in 2002 with the Sorensen devices. So I want to briefly talk about some of the projects we do at the University of Washington. And I'm not going to be able to cover them all. And I'm going to cover some projects that are not at the University of Washington related to this thing that Jeff mentioned, a mobile accessibility project. So the goal of the mobile accessibility project is to use our standard smartphone devices to enable people to do more than they can do, people with disabilities. So if we have one of these devices, they're pretty amazing. It's a smartphone. It can be tethered to a Braille device for a blind person seamlessly, especially the iPhone. So when I say tethered, there's no wire. It's just through Bluetooth or Wi-Fi. We have speech output. So that stuff that Kurzweil did is going to be useful again. We have vibration output. You can do things like the normal things, talk on the phone. You can do messaging. You can use all the web services that we use every day, Google Maps, all those cool things. Yahoo, Facebook, I don't want to leave anybody out. We can use GPS, find out where we are. And from Google Maps and other services, you can find out what's around you if you're blind. You know, what stores are available. Is there a Starbucks nearby? Whatever it is. There's a camera. You can take pictures. I'm going to talk about how the camera is used in just a moment. So we have this kind of universal device with lots of sensors. And those sensors, like the camera, can really help a blind person see the world. They just have to be able to take a picture. And hopefully it doesn't have to be a great picture. It can be a modest, not so great a picture, and it'll still be interpretable, if not automatically by humans. So this is kind of the model for accessibility for the next few years until the next big thing comes along, whatever it is. And there's still a lot to do. And there's literally hundreds of applications out there already that work on various accessibility solutions using the smartphone device. I'll mention a few of them. So UW, I'm going to mention a couple. The first one is Perk Input, which is by Shiri Azenkot, Jake Walbrook, and a few of other of us. So the idea of Perk Input is that you can use your touchscreen as an input device if you know Braille. So if you know Braille, and many, many blind people know Braille, they can quickly input text onto the screen by tapping 1, 2, or 3 fingers in the right locations. And I'm not going to give a demo of this, but I encourage you to go to YouTube and look up just search on Perk Input and see the demo of Perk Input. What I'm showing you on the picture there is just the one-handed version on a single phone. So that's the letter R, which is all 3 fingers tapped and then the middle finger tapped. So that creates a Braille cell, which is for the letter R. There's also a two-handed version for tablets and 2 phones. And you can see that all demonstrated on the YouTube video. So I think this is kind of interesting because here's, I should say, at least one result from the paper that we did, that people who know Braille can type faster using this than the standard way of using a keyboard if you're blind, which is to use a screen reader with the keyboard. And it's about twice as fast. And so if you know Braille, you can type twice as fast as you could before. And that's a big factor. So I think that's a nice achievement. I'm going to mention Tactile Graphics with a Voice, which is a new project. We're just getting a paper together now for submission. This is Katie Baker and Lauren Mill and some others. So the idea here is that you have a graphic from a textbook, and you want to make it accessible. Well, there's 2 parts to the graphic. There's the graphical part, and there's text in the graphic. And almost all diagrams and figures in textbooks have text in them. Now, there are people that don't know Braille that are blind, especially people who are late blind, and they still want to look at figures. And I can give some examples of people like that. So here's a picture of like an upward parabola and a right-facing parabola. And what's in black would be embossed, and so you could feel it with your fingers. So you have an idea what these curves look like. And then also on the same diagram are some QR codes. And if you take a picture of one of the QR codes, for example, the one on the top there, sort of on the parabola, it will say y equals 1 plus x squared out loud. And so it tells you in speech what that curve says. And that label, that QR label, will be right next to the curve so you know it's associated with that particular curve. So that's how that works. So the idea is to make scientific figures, mathematical figures more accessible in textbooks for people who perhaps don't know Braille or are very slow at Braille. So by the way, you could replace those QR codes with Braille, and we've done that, but the Braille would be much larger because it's a fixed size. So you get a little more text on your figure than you would with just Braille. So those are two projects of many, many projects that we've done at University of Washington. I want to mention a couple of other projects that I think are very notable. One is VizWiz by our own Jeff Bigham here. So this is where the camera comes of use. Suppose you're blind and you receive this letter in the mail, and it might have a check in it or something like that. But maybe you open it up and it has a check in it, but you don't know how much it is. So you take a picture of that check, and then maybe just the number on the check or something like that, not who signed it. You don't want the signature going out, whatever it is. And then it goes out to the crowd, and somebody says, okay, that's a check for $845, and it's addressed to so-and-so, and so you get the answer back right away from a human. So that's VizWiz, and there's many, many applications for this, and Jeff has given some great, great talks on it. This is now available publicly, and anybody can use it that's blind. Jeff has shown me some pictures where somebody took a picture of their credit card. Maybe that's not the best thing to do because it gives away the number. But most pictures are reasonable. Some of the pictures are not so good because blind people maybe didn't focus their camera as well as they could. So that must be the first talk next door. And the turnaround time would be, depends, on the question and, who's available and things like that, but it could be as little as 30 seconds. I want to mention Slide Rule, which is a project by Sean Kane and others. And a little story behind this is that around 2007, 6, around that time, these smartphones with touchscreens came out, and they looked like they would never be accessible to blind people. After all, there's no buttons. Remember I showed you that BlackBerry earlier? It has little buttons, and so you can feel them and learn them and things like that, but there's no buttons on this thing. So in 2007 and 8, the group with Jake Wobrock, Jeff Bigham, and Sean Kane tried to figure out a way to make these touchscreens accessible, and they were quite successful. So they found ways to traverse through lists just by doing flicking, to do a selection. So one thing you want to do is when you touch the screen, you don't want to open anything up. You sort of want to explore the screen without opening anything up. So, and every time you touch something, it should say what it is out loud if you touch something like a little icon. And then when you want to activate it, you could do a split tap, which is to tap with another finger, and that would activate that particular application. And so they invented these little gestures, and it turned out to be very successful in the research realm. And then about a year later, Apple came out with VoiceOver, which has a lot of the very same interaction paradigms that Slide Rule did. Now, VoiceOver is a screen reader, full-blown screen reader that's built into every iOS product. That includes the iPhone, iPod Touch, and the iPad. And it was the first time that a screen reader had been really built in that people found totally useful. So one day, touchscreens were not accessible. The next day, blind people were buying iPhones right and left. Why? Because of the inventions of Slide Rule. And I guess Apple maybe read that paper, and I can't say for sure. Of course, they added their own little twists and different ways to make things work, but basically it's the same ideas as in Slide Rule. So that was released a year later, and it has many of the same features as Slide Rule. And here's an example on the screen, which is the VoiceOver, and it says here, tap once to select an item. What they really mean is just put your finger on it and it'll talk. And a double tap to activate. And swipe 3 fingers to go to a new screen. Things like that. Little tiny gestures that make the iPhone and similar devices like Android accessible. There are also dozens, maybe hundreds, I'm not sure how many, it's hard to find them, apps that are already out there. Looktel Money Reader, almost every blind person has that. So you just take a picture of a bill, and it does work in Canada, even better, because the colors, the bills are different colors in Canada. In the US, it still works. It'll tell you what denomination that bill is. So it's, again, using the camera. There's a GreenGuard color ID, so you can take a picture of some garment or something like that and say, well, that's red. It doesn't do enough, though. I really would like it to say, well, here's a garment I have, my pants. Does this shirt match my pants? Well, these are black, so that's pretty easy. But they might be, for women, this might be very useful. And I have an undergraduate who's working on that problem. And there's also Braille Touch, which is kind of a competitor to Perkinput that I mentioned earlier. So here you can use two hands on an iPhone and type in Braille like on Braille buttons. Perkinput doesn't have buttons. You just tap on the screen where you've calibrated your fingers in the first place, and then it works. So you don't have to worry about hitting a particular button. And people like, many blind people use Braille Touch to create text messages, to send email messages, or just to put a message on the clipboard. I should say one more thing about Perkinput. Perkinput is now available as an iPhone app. And we're actually distributing it in a way where we've instrumented it so we can gather data as to how fast people are getting using that Perkinput, because all we have is data from the lab. So now I'm to the design paradigms. So design concepts in HCI that have influenced me. So there's design for accessibility. I'll talk briefly about universal design and ability-based design. And then user-engaged design, user-centered design, participatory design, and the title of my talk, Design for User Empowerment. So universal design, design for as many users as possible, not just the average user. So somehow, this idea of universal design really comes from architecture. And how do you design a building or an open space where people with wheelchairs can go, anybody can go, and it's kind of like, it's not a special purpose ramp or something like that. It's just the way it's beautifully designed that it's welcoming for everybody. So I have a couple of examples here. One is the Swiss Army knife, which is kind of, you can use it as kind of a universal tool to do all sorts of things. And one I personally appreciate is the keyboard tray that's universally adjustable to different heights and different things like that, which is probably good for any particular one individual, because you don't want to have your hands at exactly the same height all the time. You want to move it around a little bit so you don't get injured. So these are two devices that are kind of universally designed, that are basically meet a lot of uses for a lot of different people. So another way to think about universal design, which I like, is called ability-based design. So design to leverage the full range of human potential. And this is by Jake Wobrock, Sean Kane again, Christoph Goyos, and Susuma Harada. This is from and John Freilich. This is another, I'm kind of sold on University of Washington, another University of Washington idea. So here's kind of the standard assistive technology. On the left is a user who we're kind of representing by this angled thing, and the system is kind of a circular thing. And these things don't fit together very well. So you have a user that can't use the keyboard. Well, is there some way to get around the keyboard? Or you have a user that can't hear, and there's going to be something coming on. Maybe you need some like captions, and so on. So there's going to be something in between an adaptation. So when you add the adaptation, then it becomes accessible. So that's kind of the standard model that people have used for years. But it kind of violates universal design because, unless you're a circular user, you can't use this product easily. You need something else. So the idea is to look at all the different users, as many as possible, and make your system in such a way that you can switch from one thing to another so that they always fit. And now, if you're a particular user, you can select the option that works for you. So I'll give an example of that, and this is the iOS text-to-speech. So if you look at this system here, it has a system voice, Alex. Well, maybe you don't like male voices, you want a female voice. Or maybe you want a British accent. Or maybe you really want to have, something else. There's also a slider, the speaking rate slider. So you can slide from sort of normal, slow, or fast. And most blind people I know jack it up all the way to fast. And I can't even understand what's being spoken personally because I'm not used to it. So you can see the adaptation in this that allows many different people, many different capabilities to adapt the system to what they need. So I think this ability-based design is kind of an implementation or a conceptual way to think about universal design. So now user-engaged design, I think people are pretty familiar with these, so I'm not going to do too much. It's really a recognition that the intended users of a technology may be different than the designers. So I can remember way back when the programmers were building, IDEs, interfaces to do their programming a little bit easier, and they're basically doing it for themselves, and it worked. I mean, Eclipse and all these things have come out to really make programming a lot easier. But typically, if you're designing something where you're trying to make it universally designed, or you want it to make it useful for the most people possible, and some of those people are disabled, somehow you have to get them into the loop, the design loop. So designs with the engagement of intended users will more likely be adopted. So the intended users includes a lot more than just you, but lots of people that are different from you. And so how do you engage them? How do you get their input? So the classic thing is user-centered design. Involve the user in the design cycle. Well, you're the designer. You figured out that there's a need. You did some analysis. You design something. You think it'll work. You prototype it. Then you give it to some users, and they test it for you, and you find out, well, it didn't work that well. So we're going to do it again. Go through the cycle again until it gets perfected. And if you have this wide diversity of users, then you need a pretty big test group to do this. So that's user-centered design. I might be distorting this a bit. I think I've seen different definitions out there, but that's the one that kind of makes sense to me. Participatory design. Involve the user in the design phase. So get them in earlier, not just afterwards. So again, you found a problem. You have an idea. You bring the users in the design phase to help there instead of just waiting until testing. And then you prototype it. And then you get some user feedback from other users, not the ones that were doing the designing, but other users. And so that's participatory design, my understanding of it. So user empowerment, what's that? So involve the user in every step of the design cycle. So I'm going back to the programmers that designed user interfaces for programming. They were involved in everything, not just design. So analysis by the users, design by the users, prototype by the users, and again, user feedback. Of course, these are not necessarily the same users, the same people, but they're people like them. So if you have a project that's intended to be universal or for everyone, it behooves you to put people with disabilities on your project, because especially if they're programmers. So you're going to get a better product out of this than any of the other two. So I'm going to go into more depth into this design for empowerment. So I found 3 characteristics that I think are necessary for this. One is self-determination. So if you have something that you're disabled and you have something you need, then if you do it yourself, then you're going to want it more. You're going to probably adopt it, things like that. So it's just going to work better. Community action. Well, you can't do it alone. Usually you need partners of some form or other. How do you include them? I'll talk a little bit about that. And education. Well, you can't do these steps. You can't be a prototyper unless you can be a computer programmer. So you need to have the education. So it's not just, testing with users. It's not just having users in the design process, but having them at every step, including the building of these products, because then they're really motivated to make it right and not skip steps. So I want to mention Jonathan Kuhneholm. There's a picture of him on the cover of IEEE Spectrum from a few years ago. He's an engineer. And in the picture, you can see that he has an artificial arm that he designed. He lost his arm in war, in the Iraq War, I think in 2006. He's a student at Duke University. I think he's still a student there. But he also started this company called the Open Prosthesis Project. And there's a very interesting little picture there, the logo, which really turned me on. It's one hand that's doing the design, but that hand has a prosthesis on it. So the upper hand on the top is some kind of prosthesis, and the hand on the bottom is the kind of design. So there you can see that the person with the disability is involved in the design, and the programming. He's an engineer, so this is likely going to happen. And I've actually met him, and he's a passionate guy and is really working on this. In fact, one of these things about some people that get so passionate they never finish their degrees. I'm worried about him in that respect. I want him to finish. Kerry Sapalo. He's a guy I know, PhD chemist and professor. He's totally blind. And one of his passions is making devices for chemistry that are accessible to blind people. So he started a company called Independent Science. And he's one of the principals. I think he might be the CEO. He's also a professor. So he's building special devices for doing all the little tasks that you have to do in a chemistry lab. And he's totally blind. He got a PhD, so he got that education. So he can do this kind of thing. I like this guy, Gerry Leary. He's a coffee roaster. Why did I put a coffee roaster up there? I've met him. He's in Boulder, Colorado. He has a company there called the Unseen Bean, and it actually is online, and you can order coffee from his company. Just search for the Unseen Bean, and you'll find it. And he's actually a techie. He doesn't build stuff himself for technology so much, but he's a consumer of technology, and he loves to talk about it. And a couple of years ago, I brought my team to his coffee roasting company, and we just sat down and talked about different kinds of technology that he might use. And one of the pieces we were thinking about doing was using the little smartphone as a carpenter's level. In fact, you can download a carpenter's level because you can tell which way the thing is rotated. But the one that you get doesn't talk, and so it's not useful for a blind person. And he said, oh, yeah, I have a carpenter's level that when it's level, it beeps, but only when it's level. So it doesn't tell you how far you are off or anything like that. So, and he was really excited by this idea of having a smartphone talking carpenter's level. I think the main thing about this guy, Gerry, is that when he decided to go into the coffee business, he had to get trained. And he went to the school for training how to make coffee, and he said, no, you can't do it. You're blind. You have to look at those beans to see what color they are, to know that they're roasted properly. And Gerry said, no, I don't think so. And so, but they let him in, and it turns out you don't need to see the beans. You can smell the beans, you can touch the beans, you can do all sorts of, you have these other senses. And so he is a very successful coffee roaster. And I recommend his coffee, but it is expensive. I warn you. Another fellow I know, Ananda Bhattacharya, we call him Bappin. He has a name sign, Bappin. He's both deaf and blind. And he has this little motto that It's kind of amazing. Life is meant for living, and there's simply no room for regrets. And one day I'm going to ask him, where did you get that idea? And he just lives life to the fullest. He's married, he has kids. He has his own company, the Bappen Group. He started it last year, and his group does training. It trains other deafblind people to use the iPhone, this time tethered to a Braille device, so that they can read what's on the screen in Braille. And is really making a huge impact on the deafblind community worldwide. So here's somebody, this is that community thing I was talking about earlier. So he's a technologist. He once told me he wanted to go for a PhD, but he's doing so much good right now. I don't want to push him in that direction. So a little bit about community action. One group I really admire is the National Federation of the Blind. It's one of the few organizations for people with disabilities that's passionate about education, especially in science and technology. And I'm showing a picture of Natalie Shaheen, who's the Director of Education at the National Federation of the Blind. And both Jeff and I and others, Sean, I've all worked with them and on various projects with children as young as 8 to 12 years old, all blind, teaching them how to use smartphones, how to program, how to do instant messaging, applications, all sorts of things. So another one is this RS Games. I met this guy recently, Michael Forzano. He's also blind. He's also pretty deaf. He got tired of everybody playing games, but these games weren't accessible to blind people. So he and his friends started this sort of group called RS Games, and they write their own programs and their own games, and I think they have about 20 different games. So you can go online and search for RS Games and play games with them. They'd be happy to play with you. They're all cooperative type games. So this is like that community thing, getting together to solve a problem. There aren't enough games for blind people to play. Well, let's invent our own. But you can't do that unless you're a programmer. So these guys are highly skilled. And these programmers have their own listserv, and they help each other out in terms of issues that come up with accessibility in programming. So that's the kind of thing that we need more of. Finally, education. Empower people to solve their own accessibility problems. So there's actually a saying that goes back to the 6th century from Lao Tzu, father of Taoism. It says, give a man a fish, you have fed him for today. Teach a man to fish, and you have fed him for a lifetime. So now we're getting around to this education theme, that we need more people with disabilities in HCI, but they need to be educated. You can't just walk in and start doing this work. So I want to talk about Nicole. Nicole is somebody I actually met in high school, and Jeff has known her a long time as well, and Sherry, and Sean too, because she worked with us at the University of Washington, even when she was in high school. She was a consultant on that tactile graphics project that Jeff mentioned. Well, when she was in high school, she had a problem. She would do her math in the Nemeth code, which is a Braille code. And then sometime later, somebody who knew the Nemeth code would come around and change it to annotate it with the math. And then finally, the math teacher would see what Nicole had done. And usually, of course, it was correct. She was very smart. But this was a 2 or 3 day thing to get her grades back. So she was getting her grades back after everybody else, and she was frustrated because she wanted to have her feedback with everybody else. Well, in the summer of 2006, we had a workshop at the University of Washington. We had about 45 blind people there, and Nicole was still in high school. And one of the sessions in that workshop was on math accessibility. And it was led by another student of mine, Sang-Young Han, who is also blind. And for his math accessibility, he knows Nemeth code, but he also knows LaTeX, and he can read LaTeX. LaTeX is a markup language like MathML. And so Nicole learned about LaTeX and MathML, and so she had a brilliant idea. what was the idea? Well, the idea was, well, she knows Nemeth code. Her teacher doesn't know it. But what if I translate the Nemeth code to LaTeX and then have that LaTeX compiled and printed, and it comes out to be beautiful math in the end, like highly produced math. And so she built that as a high school student. Well, how did she do it as a high school student? Well, she took AP Computer Science 1 year and then a second year of it. So she had already, in high school, become a programmer. And so she could design something and build it herself. And it was something that was so useful that it became a small company, and she sells it to other people. So it's one of the few Nemeth to LaTeX or MathML translators out there. And that's when she was in high school. And then she applied to college. She applied to University of Washington. She got in. She applied to Stanford. She got in. She went to Stanford. And I've actually supported that. She came to University, I would have supported that, whatever she wanted. And she was a computer science major at Stanford. She graduated. And now she's, I think, in her second year as a Google engineer. So she works in Mountain View for Google. And she's very well known there and still a great problem solver. So this is that education piece I was talking about. Without that education, she couldn't solve her problem. In fact, it wasn't really her problem, it was her teacher's problem. Her teacher didn't know Nemeth code. In the end, when she turned in her math after this translation, she had the most beautiful math in class. It was professionally done rather than handwritten. So here's a picture here of the Nemeth code on the top, which is annotated. The next section is the Nemeth code translated to ASCII. And then the next one is the LaTeX. So that's the Nemeth back translated, which she built and designed. And at the very bottom is the math that the teacher got to see at the end. So you can see why I say it's the best looking math in the class. So that sort of ends the major part of my talk, and what I mean by design for empowerment. So I want to talk a little bit about this project, AccessComputing, that Jeff mentioned earlier. So this is, I think we're in our 9th year at the University of Washington. It's led by myself and Cheryl Burkstaller, who is an amazing woman. She's the co-PI and director. It's between the Do It Center, which Cheryl runs, and Department of Computer Science and Engineering. And it's a national effort. It has one goal: increase the participation and success of students with disabilities in computing fields. We had a review in January this year during our 8th year, and it was rather a rave review from National Science Foundation, external reviewers. And they wrote a letter to the director, the assistant director of SIGCHI, saying this program should continue, even though it's being sunsetted, because it'll be 10 years. We'll see what happens. So here's some pictures of, that's Sang Young Han on the bottom left. That's the blind student that taught Nicole how to use LaTeX for math accessibility. And on the upper right is Zach Ladner, who was a math major at the University of Washington. And here's a student who worked with us. That's a deaf young lady who worked in one of our projects. I think it was a Saturday computing experience that we ran over the last 3 years. And here's a person with a physical disability who's working on a project that I did back in the 1990s there called The Game of Life. Well, we don't do this all alone. We have a lot of partners, including all these universities. I think we have 17 or 18 universities. We just got a new one on board this week. And a bunch of other organizations that are interested in broadening participation in computing for underrepresented groups, not just people with disabilities. So it's been a great time to do this, because I don't just work with people with disabilities. I work with people that work with African American, Hispanic, Native Americans, and so on. So it's kind of fun to be kind of in that big family for broadening participation. And if any of you out there are academics and are interested please come up to me afterwards and we can talk about how you could become a partner in this effort. We have 2 strategies, direct interventions. That's me with some 8 to 12-year-olds at the National Federation of the Blind doing a computer science unplugged activity called sorting. And so we sorted by their ages and we sorted by their cane lengths and had a lot of fun with these kids. And we also try for institutional change. And part of the institutional change is going on here at CHI. So Jonathan Lazar, who is one of the major players in the CHI leadership, is really working hard to make accessibility a priority for the CHI conference and for SIGCHI generally. And if you're interested in that effort, please come and talk to me afterwards as well. I think there's been some great improvements in the last few years and more needs to be done. So I think, but we're also working with universities and also those other broadening participation organizations to help them become more accessible. I wanted to mention this one page. This is our web page, but this is a page called Choose Computing. And on this page, we have profiles of students with disabilities in computing fields, and they're really detailed profiles. And it's really, kind of inspiring to read some of the stories by these students. Not all of them are students anymore, but at least they were students that we're working with in AccessComputing. And here they are. There's 17 of them. And there's Sean Kane again, that he's one of our people that has worked on this. There are people that are deaf. There are people that are blind. There are people that have different. A number of these people are in HCI. Not all of them, but they're all in computing fields. I'm going to talk about a couple of them. Vincent. Vincent might be at this conference. I'm not sure. He's studying HCI as a PhD student at Georgia Tech. And he works with Bruce Walker. He's very interested in sonification research. That is, using not just speech, but other sounds to make computers more accessible. And he's just done an amazing amount of things in the Atlanta area. He's the vice president of the Georgia Radio Reading Service, of all things. So he's not, this is that community thing again. He works with his community, and he's a PhD student. So he's somebody you guys should think about hiring if you're on the faculty out there. Kavita. She is severely disabled. She could basically move about one finger, and it's degenerative. But she's determined to get a PhD. She already has some publications. She's at the University of Maryland, Baltimore County. She's very interested in human-robot interaction. And she was on a panel of mine a while back, and somebody asked her, why did you get into computing? What got you into computing? And what she said was, I wish I could quote her exactly, she said, well, with a very little action, you can do so much. You can do so much. So the computer is an amplifier. It can amplify her needs, her abilities, her desires to make them actually happen, as opposed to having other people do it. So that's why she's in robotics, to get these robots to do things that she can't do herself. So I'm really rooting for her to get her PhD. So this is my final slide. So HCI needs the expertise and perspectives of researchers with disabilities to spark innovation. So thank you very much. If there's any questions, there's a microphone right there. And please use it because it's a pretty big room. And we're being recorded.
Good afternoon. Is it on?
Is it on?
Hello, hello. No. Is it? Okay. All right. So hi, I'm Michelle Williams from UMBC. So I had sort of a concrete question about the CHI conference. So I noticed that they sort of lumped all of the accessibility research into one session. For instance, like one of our colleagues has a paper on like chairables, and so all the other sessions seem to be about the technology, and they have these cool names, and they're lumped by that. But then when we went to look for his paper, it was lumped with, it was like the title is just accessibility and the populations are different, the technology is different. It's just that they happen to work with people with disabilities. So I'm kind of wondering your take on that, and with that, also your point about, disability research eventually becomes quote unquote mainstream or for everyone. I wonder if you have any sense of how long that takes and whether there's just a natural progression, or we should be more advocates for the more universal design approach earlier on to make that less organic and more forced so that we're in all of the sessions all the time from the beginning.
I think I should, there's no answer to that question except that I endorse what you said. I think if more people in the CHI community sort of took on the idea of universal access or universal design or design with empowerment, the conference would be different. And I think that would be a cool thing. But on the other hand, there's a lot of creativity here. And sometimes you do have to not think about disability for a while and just kind of be creative. But then you should bring it back in and make sure you don't go too far without considering, the 1 billion people I talked about earlier.
Hi, David Forney, Ryerson University. So, of course, I've spoken to you before. I was at the STEM talk in Rochester about 6 or 7 years ago where we discussed, I was actually the only international participant. It was odd. We discussed this whole issue of how to encourage deaf and hard of hearing people to go into STEM and STEM-related fields. But what I wanted to ask you or press for an opinion on, whatever, is not everybody is into computer science, right? Not everyone wants to be a coder, although personally I think everybody should learn how to read code. Everyone should actually learn coding skills, but not everyone wants to be a coder in the professional sense of the word. How do we encourage a broader sense among the community of people with disabilities to consider a STEM career, or at least consider, if you will, encouraging their inner geek? Let me put it that way. And so that's the first question. The second question I have is, so in addition to CHI and other similar human-computer interaction-oriented conferences, we also in the ACM have the Assets Conference, which is very specifically oriented to disability and accessibility. So should we, as researchers in disability, or in my case, as a disabled researcher who is in disability, which is also a very rare thing, not many disabled researchers want to get into disability, should we have a conference that is oriented and focused on this specific thing, or should we be really pressing for CHI, for example, to push for accessibility mainstream in every possible paper, research, that kind of thing? Those are my questions.
Mm-hmm. Okay, for the first question, I mean, I've done my damnedest to get as many students with disabilities to be excited about STEM fields. Jeff mentioned the over 80 students that were in my summer academy over 7 years, and I'd say about a third of them are in computing, and maybe another third are in some other STEM field, and the other third probably are doing something else. So yeah, I think we've been pretty successful with that, and I think my message today is all about that, is getting more people with disabilities into and opening it up and making not only our conference and CHI more accessible, but our education programs that people represent out here. And our companies. Facebook should have blind people. Google already has them. They probably should have some more, and so on. So, and now for the second question, I like the Assets Conference. I don't think, you want to have everybody doing this. You want people that have a passion for it and so on. But those people in the CHI community should respect that work, admire that work, and hope that they could do as good a work themselves. Yeah.
Hi, Ed Cutrell. I'm at Microsoft Research in India, and we do some work with disabled populations, particularly in rural or in sort of dispersed areas throughout India. And one of the things that we see a lot of in India, and I think this is true in other places to a lesser degree, is the intense isolation associated with a lot of disabled populations. And people are really, you know, they're often sequestered. You're blind, you're deaf, well, you're just left at home to be taken care of. And one of the things that we've seen with some technologies is, particularly ICTs, is the ability to sort of connect those people or open up the world to some others and communities. And I wondered if you could talk a little bit about your experience or some other projects that you know of that are specifically aimed at that notion of connecting people or sort of opening that up. I mean, a lot of the things you talked about today, some of them were communication kinds of things, but I wonder about this notion of communication as community a little bit.
Yeah, that's a really interesting question, and I don't know if I can have a third career, you know, which is to do, you know, work internationally. I did mention the convention, and I think over time, as these countries implement the convention, things will open up a bit, and the people that are now sheltered in their homes will get out of them, will have jobs, will be productive, and so on. So I think it's a slow process. Connecting these people to the rest of the world, I think it's a really great thing to do. And I believe, you know, that's a major step so that they're not so isolated, that they know that there are other people like them and that there are successful people, role models, and so on. And I think, you know, of those 1 billion people in the world I mentioned, probably 3/4 of them are from countries that can't afford a screen reader or people can't afford stuff. So in the convention, the technology piece I read talked about low cost. And so I think it's a major challenge for us is, you know, we can do these, you know, $20,000 robots that carry somebody off a battlefield. That's wonderful. Let's not have any more battles. We don't really need those people. We don't need those robots. We shouldn't be using those robots for that purpose. Let's not have battlefields. But I think, you know, that energy, that money could be better spent on those 3/4 of a billion people with disabilities around the world that don't have any technology at all.
Jeff Bigham again, Carnegie Mellon.
Closer.
Jeff Bigham again from Carnegie Mellon, maybe? Walked all the way back here. Okay, so I guess one thing I'm interested in is I'm very convinced that you and others running programs are able to have an impact, so are able to increase the number of people with disabilities who participate in, say, computing. But I think one of the end goals of a lot of these programs is to kind of see that exponential return or like that self-sustainability, that snowball effect that, you know, at some point, you know, you don't have to have people working so hard just to, say, make sure a person with a disability can be in a computer science department, right? Are you seeing that, and do you have particular ways you look at how we might make that happen?
Hey, you stumped me. Well, you know, I mentioned AccessComputing, and we've worked with a lot of departments to help them make their web pages more accessible. It's not just making your web page more accessible, but more inviting, more welcoming. So if on your web page, it's all a picture of these males, geeks, with long hair, beards. You know, you're not going to attract women. So it's the same thing for disability. So on your web page, you should have a person in the wheelchair. You should have a couple of people signing to each other. You know, show things that are really diverse. And I think that's one thing. Now, there was a two-sided thing. There's the students, working with the students to get them prepared. The other side is you people out there that have programs, making your programs more inviting, making them, instead of, sort of brings me back to a story. So a couple of years ago, we had this Saturday computing experience was for deaf kids to come to the University of Washington on Saturdays and work for about 2.5 hours on, you know, things like Scratch and Alice and stuff like that. Well, one year, there was this young lady who came and who wanted to come, but she was not only deaf, she was very low vision, and she had cerebral palsy. So she had very limited mobility. And so the parents of this young lady came to me and said, well, can my student come? And the first thing I said was yes. You know, I didn't say, oh, well, let's see, you know. And I invited them to come to the university. I showed them what we were going to do. I, you know, was very inviting, and that person did come. And they spent 8 weeks with us every Saturday. And we had sign language interpreters, we had extra large screen, we set it up to make it accessible as possible. So the sad part of it was, I don't know, how many people know what Scratch is, the programming language Scratch? A lot of you. Well, you would think it was that somebody who's deaf, Scratch would be very accessible. But it turned out it was not accessible to this young lady because of her mobility issues, not because she was deaf or had low vision, because Scratch was designed in a non-standard way, so you had to have this very fine acuity to move one of those blocks from this area to this area without activating it. And so, you know, why did they do that? They didn't think about anybody with a mobility issue. So I think some of it is the stuff we're designing, you know, that would be inviting for kids with disabilities are not yet. So I'm working with Andy Stefik from University of Nevada, Las Vegas, on making one of the activities in code.org's Hour of Code, at least one activity, accessible. So I think that's the kind of thing we need to do, is just wherever you see it, fix it. Okay, so I think we're pretty close to out of time.
I don't want to hog the mic, but David Forney again. I don't want to hog the mic, but your thoughts brought up a couple of more questions. Sorry.
Do one at a time, and then it'll be easier.
Yeah, I'll try to just throw one at you, and that is, you know, we've been discussing this whole issue of, okay, we need to have people with disabilities involved. We need to have designers with disabilities involved. We need to have, you know, all this stuff going on. You commented even on the need for companies like Facebook, Google, Microsoft, whomever, to hire these people. So that's basically my question. We're clearly, you pointed out, we have large numbers of people with disabilities pursuing PhDs in STEM fields. So how do we get them hired? How do we get them into high-paying engineering roles where they're taken seriously?
Okay. I know our time is up because I can hear a lot of people outside, so I'll make this answer quick. I can't make them. I can't make them do it. They have to see the business, why they need it. And I think I explained that today. They need it because they want to have the best product. Why did Apple make their VoiceOver? Because they're good guys? No, because they could sell more of these things. There's probably 50,000 blind people that have bought iPhones that didn't buy anything else. So they made money on that. So it's a business proposition for those companies.